Okay, let's look at some examples involving specific heat and latent heat of fusion or vaporisation. So if you had a question here, we've got to melt 2.5 kilos of ice at 0 degrees Celsius to a water temperature of 20 degrees. So we're going to change it through being ice to water, and then we're going to raise its temperature. So there's two parts of this. So if you look at it here, what you're trying to do here is first of all change the ice to water. So that's going to be involving the latent heat change. So we're going to use that one there. And we're using the fusion one from ice to water or water to ice. So in this case here, we need to actually change the 2.5 kilos of ice, fuse it there with that one there, and that'll do the total heat just to actually change the ice to water. So that'll be 8.35 by 10 to the 5 joules. So having converted it into water, we now need to raise that temperature from 0 degrees up to 20. So we're not going to use latent heat of fusion here, we're going to use specific heat in this one. So that's the MC delta T one. We're using water for all these. So the mass of the water is 2.5 now. The specific heat of water here is 4.18 by 10 to the 3 per kilogram. And then we want to change the temperature. So the temperature change here is from 0 to 20. So what you're really doing here is you're doing the final temperature, subtract the initial temperature, the starting temperature. All right? So I'm going to cheat here and just go, that's going to be 20, take 0. Okay? So that's 20. So based on that, we get 209,000 joules. Okay? So this is to change to raise the temperature. So altogether, we want that plus that to give you the total. So it's 1.044 by 10 to the 6 joules. So in other words, it's a megajoule. It's a million joules, just over a million joules, just to do that conversion there. Okay? So what we're going to do here is we're going to get steam condensing onto the glass filled with ice maybe, and the steam starting at 110. So first of all, that steam's got to cool down to a 100 degree state. Then it's going to turn into water. It's going to form 1 gram of water. And then the water is going to be cooled down to it's only 5 degrees, probably because the ice in here has made this really cold. So there's quite a few changes going on there. So if you have a look at it, you've got to first of all cool the steam down from 110 to 100. There's your first change. So to do that, we're going to use Q equals MC delta T. Now you have to be careful here, because if you assume the specific heat of water is the same as steam, you'd be wrong. I didn't make that mistake. When I looked it up, it's actually different to the water one. All right? It's actually slightly less to convert steam's temperature than convert water temperature. So the mass of steam we're going to end up here being converted there that we're focusing on is only 1 gram. So 1 gram is 1.0 by 10 to the minus 3, or 0.001. Now the specific heat of steam, well, it's a steam form, it's like this, 10 to the 3. And we're going to change the temperature just by 10 degrees here, because it's going to be final, take initial. So it's going to finish off at 100, and it starts at 110. So what you'll notice there is you get negative 10. So here it's going to drop down. And that should indicate you're going to get a negative number here, because it's going to lose energy. It's going to lose heat energy. So looking at that, you get minus 19.96 joules. You can round that off to 20, really. So there's minus 20 joules there. So it's going to lose 20 joules just converting from steam at 110 down to 100, okay? Now when it actually hits the glass then, it's going to go through another change. We're going to get steam going to water now. And in that case, we're talking about latent heat of vaporisation. All right, gas to a liquid. So we're going to use this one here, ml vapour. So for that one, the mass is 0.01 grams still. Sorry, 0.001. 1.0 by 10 to the minus 3. We times that by the latent heat of vaporisation for water, and you get 2.26 by 10 to the 3 joules. All right, or 2,260 joules. So we're nearly there now. So the last thing we need to do is change that water temperature now from 100 down to 5. So we're going to go from the water. So water temp from 100 down to 25. So this time, we're going to use Q equals MC delta T. Okay? And this time we're using the mass again of 0.001 times by, the specific heat of water here, 4.18 by 10 to the 3, times by, and we're going to change temperature from, we're going to finish at 5, and we start at 100, so we're going to go 5, take 100. Final, take initial, minus 95. So again, it's going to release energy, and I should point out here that this one's releasing energy as well. All right? So looking at that then, you get minus 397 joules. We've got this energy released when the water is cooling down. We've got this energy released when it changes from steam to water. And we've got this one here when the steam cools down. So you would need to add those three together to get your total energy. Okay? So they're the sort of questions you can do with these two formulas. So one's the fusion one or the vaporization one, and the others are about specific heat depending on the material you're using. Okay, thanks.